join me on the floor to give your discours. Comment by this power? I am going to give a short introduction about your career first. So, Jean-Pierre Gratia is a biologist. You got a PhD and also what is called l'agrégation de l'enseignement supérieur. That is a second doctorate. I did not have this tedious work to write a second thesis, you know. One was enough for me. So then you got your PhD in 1974 at the University of Liège, and then you went to the Free University of Brussels, then where you pursued a scientific career at the Laboratory of Microbiology at the Faculty of Medicine. After 1999, you were a free research worker at the Pasteur Institute in Brussels as well. You published almost 100 scientific articles related to the bacterial genetics, molecular genetics of lysogeny and transduction, and about the discovery of a gay case of sexuality in a bacteria. You are also a prolific writer because you have written and edited several books. One of which of a particular interest for us is now on the screen. So, Jean-Pierre, it is really our pleasure to give you the chair in order to evocate your father.
Me the opportunity to speak about my father and his remarkable contribution to science during his brief but impactful career from 1920 to 1949. My time with him was very short, limited due to untimely death in 1950, and I was just 16. And because of a 2-year separation from my parents during the war, during the years we lived with him, my brother and I were very happy because he was exceptionally kind and attentive. He was always helpful, constantly smiling, and had a great sense of humor. In the Ourthe and the Amblève rivers with my brother. After identifying the coagulating agent produced by Staphylococcus as an enzyme, which he named staphylocoagulase, he discovered a paper by Frederick Twart in the library of the Medical Center of the Rockefeller Institute, and inspired by this paper, he began researching lytic agents against Staphylococcus. He discovered a staphylophage, which after extensive experimentation, he found to be similar to plant and insect viruses. He was a proponent of the viral nature of bacteriophages, unlike his supervisor, Jules Bordet, who discovered lysogeny, but was more aligned with early ideas that would rather lead to the prion theory. At the same time, he introduced phagotherapy in medicine independently of Felix Terrel and the Professor Richard Bruno-Guénézet. This conference was possible to the global research on bacteriocins since 1945, when the laboratory in Liège began investigating antibiotics. At that time, my father and his assistant, Pierre Frédéric, looked for E. coli strains capable of producing substances similar to what he had discovered in 1925. This was after a 20 years period of scientific and medical indifference. Following Frédéric's thesis on numerous similar substances named colicins, French scientists François Jacob and Pierre Schaeffer discovered a colicin-like substance, pycin, produced by Pseudomonas pycina, and megacin, produced by Bacillus mycobacterium. Wolff later proposed the term bacteriocins for proteinous substances that specifically attack bacteria of the same species as the producer, and after binding to specific receptors on the cell wall. I must highlight a significant discovery by Pierre Frédéric, who identified a plasmid carrying the gene responsible for producing colicin-1. This plasmid was later found to be a circular DNA with a unique site for cleavage by the endonuclease ECOE1, which allowed the insertion of foreign DNA. This marked the beginning of genetic engineering. My father was a forerunner in bacterial and viral genetics. In 1923, he used two bacteriophages distinct by serology, heat sensitivity, and plaque morphology. The one forming large plaques and the other small plaques. Only rock bacteria were resistant to the large plaque forming phage, and only smooth bacteria were resistant to the small plaque forming phage. Since the rough smooth variation was observed in the absence of any phage, he could conclude that the two phage resistances were genetically distinct characters arising independently of the agents used to select the resistant bacteria, in contrast with the current ideas at the time, and in agreement with the Darwinian concept. Moreover, about only 12 years later after, he discovered that mutation can occur in a virus, as he was working with phage lysate of a lysogenic Bacillus megatherium. This lysate normally produces turbid plaques on non-lysogenic sensitive bacteria, but he observed that phage from each turbid plaque could generate a very low clear plaque. He then established that the clear plaque and turbid plaque characters were maintained in the progeny of phages from well-isolated plaques. From clear phage lysates, he was then able to isolate a second step mutant, also capable of lysing the lysogenic strain, that is to say, resistant to the immunity repressor, with reformation of clear plaques. The importance of this unknown observation in a virus did not emerge until 1950. Among the, about in 1935, he was adapting the Henriette Huguenot ultracentrifuge, which used compressed air to sediment viral particles at 200,000 revolutions per minute. You can see him.
No, he is going to appear very, very, very soon. If you just.
Gratia, who made significant discoveries about nucleic acids. Together with him and Raymond Jenner, he characterized and studied the virus responsible for grasserie in silkworms at the biochemical level. Céline has asked me to mention a direct contribution of my father to medicine. He successfully treated my cousin André Capon's severe staphylococcus infection with the renowned microbiologist. This medication, initially produced at the Brussels Pasteur Institute and later in Liège, but unfortunately not yet by pharmaceutical companies, consisted of a mixture of culture filtrate from a Streptomyces strain, later found by Maurice Welch to contain bacteriolytic enzymes and an antibiotic, and debris from Staphylococcus bacteria killed by this Lancet, representing antigens. As for an anecdote about him, I recall asking my mother if Fleming, despite his claims, was aware of my father's work on penicillium. She replied, of course, he knew it, but he was Scottish. I am not sure I fully thought to understand the remark at the time. Thank you for your attention.
Sharing and all that. So thank you so much. And stand up, please, for Jack.
Yay!